This lesson video, we want to compare multiple alternatives. When I say multiple alternatives, it means two or more with the IRR, internal rate of return analysis. Before I get to the procedure to do the IRR analysis with multiple alternatives, I give one scenarios. Suppose I have $2 million, millionaire, see that? So you should advise me which project I should invest or which alternative I should invest. Project number one, initial cost I need to put in for that project is $1 million, and a guaranteed return, internal rate of return for that project is IRR 1 for that project 1 equal to 10% per year. And then another alternative, project 2, with the need initial cost is $2 million and a return IRR 8% per year. And tell me which one I should invest. Remember, I have $2 million. And with this, by now you see that these two projects are mutually exclusive because I only have $2 million. If I go with project 1, then I cannot go with project 2 because project 2 needs $2 million. If I go to project 2, all my $2 million is gone, I cannot go with project 1. So I need to choose either 1 or 2. Of course, you can say, do nothing, don't do anything. But in this case, I want to use my $2 million to make more money, and tell me which one I should go. And of course, I need to tell you what is my expected return. So I have a few scenarios that I'm wondering. What if my minimum attractive rate of return is 5% per year? Which project you should advise me to go with? If 7% per year of minimum attractive rate of return, that is the hurdle rate that I need to get above that, then which project, 1 or 2, I should go? And with 9% per year, then which project I should go? Clear? Pause this video and think about with 3 different scenarios. 5% per year, which one I should go? 7% per year with method with project I should go. 9% per year with project I should go. Think about it. Pause, think, and turn on and see which method, which project I should go. So 8%, 10%. Project 1, 10%. Project 2, 8%. Some of you just say, why not go with the higher return? 10% per year, right? But it's not always the case. Not always the case. And now I'm going to show you when we go with project 1, when we go with project 2. Let's see backward. The first scenarios, my max, the minimum attractive rate of return is 9% per year. 9% per year. Then remember, in the first lesson video, what do we say? IRR greater than MAR, financially viable. If it's less than MAR, it's not financially viable. So if the MAR, that my minimum attractive rate of return is 9% per year, then for sure project 2, the IRR only 8% per year. It's less than MAR 9% per year. It eliminated immediately. It's not financially viable. I better to go somewhere with 9%. I don't go with project 2. So if it MAR is 9% per year, I should go project 1. 10% per year, greater than MAR. Project 2, 8%, less than MAR. Project 2, automatically not financially viable. Eliminated. Make sense? So that 9% per year. How about 5% per year? 5% per year. Minimum attractive rate of return, 5% per year. Should I go with project 1 again? Or should I go with project 2? Now, let's see project 2. What if I go with project 2 with my minimum attractive rate of return is 5%? So as you can see, 5% in the MAR, both Project 1 and Project 2, in my perspective, it's financially viable because it's greater than my 5%. Make sense? 10% greater than 5, 8% greater than 5%. So both 1 or 2 financially viable. So the next question is, so both are viable. Which one I should go? 1 or 2? 1 or 2? Both? Think about it and tell me. Now, if I go project 2, how much I get? So with 8% per year, I invest all of my $2 million to project 2, $2 million. So per year, I get 2 million times 8% per year. So every year, I get the return 2 million times 8%. It means 160,000 per year. That return to me every year, 160,000. If I go with project 2, tell me, what if I go with project 1? How much? If I get more than 160,000 per year, then I go with project 1. If it's less than 160,000 per year, go with project 2. Very clear, right? Now, if I go with project 1, with my 5% per year, project 1, $1 million and 10% per year. So if I put that $1 million, 10% per year, 1 million times 10%, I got 100,000 per year for the 1 million I invest. But remember, I have $2 million. I have 1 more million. What should I do? That 1 million. And that considers something we call opportunity cost. I'm rich. I'm $2 million. I'm not going to keep my 1 million left after I invest in project 1 in my house. That is unsafe, not generate more money. No one going to do that. I have to invest somewhere. And that consider opportunity cost. You have to consider opportunity cost when you evaluate the project. And that one here, I have $1 million extra if I put in project 1. So if I put project 1 with 10% per year, I earn $100,000 per year. And the 1 million left, I consider that I put in the mark 5% per year somewhere else with the minimum attractive rate of return. In this scenario, 5% per year. That 1 million times 5%, it means 50,000. So if I go with project 1, the first 1 million in project 1, I get $100,000 per year. The 1 million left I put in the minimum attractive rate of return, I get 50,000. The total I get if I go with project 1 is $150,000 per year for return. Remember how much we get for project 2? $160,000 per year. What does that mean? If it's 5% per year, I better to go project 2. Project 2. Make sense, everyone? 9% per year, I go with project 1, as I stated earlier. 5% per year, then I go with project 2. So 5% per year, project 2. 9% per year, project 1. 7% per year. Now you can be able to pause and you be answer for yourself, right? If it's 7% per year, project 2 remain unchanged, $160,000. Project 1, if I go with project 1, I get 100,000 for the first $1 million in project 1. I still have 1 million left. I have 2 million, remember? Then with 7%, I get 70,000 more, so 170,000. So if I go project 1, I got 100,000. My 1 million, I get the minimum attractive rate of return, 70,000. I got 170,000. Project 2, I still get 160,000. So it better go with project 1. So what does that mean? With the mass 77% per year, I better go project 1. 5% per year, I better go project 2. 9% per year, absolutely project 1, because project 2 is not financially viable. So the bottom line in this scenario, as you can see, is not about the compare the IRR that you see 10% greater than 8%, so go with 10%. It's not like the NPV method that we talked in the previous lesson. Whichever the greatest NPV, you go with that alternative. Here, not like that. Not the one greater IRR. Make sense, everyone? It depends on the mark. And with that, how can we do? And that we call it selection from multiple alternatives with IRR. So what are the procedure? First, we order the alternative by increasing initial investment. If you have multiple projects, for example, have project 1 million, 2 million, so you order alternative by increasing initial investment. Project 1 million, then project 2, higher initial investment, 2 million, then project 2. Calculate IRR of do nothing or cheapest alternative. Do nothing, it means you don't do anything, zero return. It might be a good try, because if you try another one and it's lower than mark, it's better to do nothing. Go with mark. Make sense? So with that, we have calculate IRR of do nothing or the cheapest alternative. And yes, go back to problem 1. Set NPV equal to 0. Find the I star. Plug in your calculator. By now, you should be able to practice in your calculator to find out IRR with NPV I star equal to 0. Just like that. Equation here in problem 1. Practice that yet? Plug that in your equation to find out. And then the next step 3, one by one, calculate the incremental value of each challenger with the best alternative found so far, defender. What does that mean? In here, one by one, calculate. This is only 2, so we compare 2. If, for example, 5% per year mark, okay, then we have the first project 1, I find out 10% per year for IRR. Then it greater than 5%. That better than do nothing. Project 1 is better than do nothing, because the internal rate of return of project 1, 10% per year, greater than my assumed first scenario, 5%. Then step 3, you want to know whether it's better to put more money, jump from 1 to 2 millions. We talk about opportunity cost. It makes more sense to put more money, to jump from project 1 to project 2. That is step 3. Should I put extra 1 million? And with 5% per year, you remember what we said earlier? Yes, we should do that, because we get 60,000 extra compared to only 50,000 if we put in project 1 million and get the minimum attractive rate of return for the remaining 1 million, 5% per year. So those are the steps, and that we call challenger and defender. Defender is the best alternative found so far, and then the challenger is the next one. And why that? I make you a metaphor before I conclude this videos. I search for the UFC fight night, so that fighting, and the next UFC 253. I'm not going to advertise that, but boxing or things like that, but just for convenience, as you can see here. So the next boxing here, the time, and in Abu Dhabi, and of course you can search that as well. And with that, you can see for the middleweight title with Israel Adesanya and then Paulo Costa. So that is the 2, and this is a defender, the best found so far. Whoever want to become a defender, this is a challenger, have to fight. So if the defender continue to win, then he become a still defender. If the challenger Paulo Costa win, he become a new defender. So I go to the ranking of UFC website, go to the ranking, middleweight champion. The current champion is Israel Adesanya, that one here. So he a defender. And Paulo Costa, Robert Whittaker, I think not in this fight, but as you can see, they have to rank. Just like we in the method here, we have to rank all the alternative by increasing initial investment. So it always starts with the low investment, get a higher return. It's better to get more money with the low investment. Unless you justify, you put more money in, and that go to step 2 and 3. And similar to here, Adesanya is the defender. Paulo Costa have to show that he better than Adesanya to become a nuke defender. And as you can see the ranking here, so exactly the same method we're talking about here, challenger, defender concept. And in the next problem, problem 2, we apply only step 3, just to know how to do the challenger, defender, fighting the two. And then problem 3, we go on of the 3 step, 1, 2, 3, with multiple alternative.